Let's talk about problem 5. Got here it says take home. It's all take home. This is a mechanical advantage problem, and so we're interested in finding mechanical advantage, which of course is mechanical advantage is F out over F in, and we're going to assume that's V in over V out. Now, as we read the problem, the input force is applied at G, so we need the magnitude of Vg, and the output force is applied at D, so we've got Vd. Now, if we look at Vg, it's on a link that's connected to ground, and so before we go any further, we can draw our graph of this mechanism, which we've got ground, which shows up in 3 places, so it's a ternary link. And so we'll have 3, 2, 4, and then attach to 3, we'll also have 5, and then 6, which is connected back to ground. All right, so that's a classical form for a Watt chain. Now, this is a slider, and the joint between 3 and 4 is a slider. The rest of them are revolute joints. And so we have O2, B2, O3. Between 5 and 6, we've got D, and between 3 and 5, we've got C. Now the slider, we're going to need a point for the slider, and so we'll have a point 06 that probably about right there is convenient. So I'll call that point 06, and that should be directly above O2, just for convenience sake. The other slider we have is between 3 and 4, and we're going to use point B2 for a point on link 4, and then for our point on link 3, we've got a choice of either C or O3. Anticipating that I'm going to want to use this loop, I'm going to use O3 for the point on link 3. Okay. C would also work, but that would work for the larger loop. Okay. So, this is loop 1, and let me see here. I'll call this one loop 2, and those will be the 2 loops I'll use. And so, for loop 1, we have points O2, B2, and O3, and then back to O2. And so you can choose any point as your start point that you're kind of set up to use O2 as your start point, with it being the first and last there. And we can go from O2 to B2, and then O2, O3 to B2. Okay, and so what that gives me, let's see here, let's move that up so that vector's shown, and then I've got O2 to B2. So that's my first loop. So call this one R1, this one R4. It's keeping track of that slider, I think 4, and this one R2. Now for my loop 2, I've got points O3, C, D, O6, and then back to O3. And so I'm going to go on one side of my equation. I'll start at O3, and then on the other side I'll go O3 to O6, and then to D. And so for this equation I had R2 equals R4 plus R1. Here I'm going to have O3 to C, that's a new vector. So that's R3. C to D. So those are the loop points I'm using. And let me see if I can keep those sort of on the screen while I'm doing some drawing. Okay, so I've got R3 that went from O3 to C. C to D was R5. And then we're going to have O6 to D, which we can call R6. And then we'll have, let's see here, I've already got R1, R2, R3, R4, R5, and R6, so this will be R7. And it's going to go from O3 to O6. All right, so I've got the setup of my loops and my vector equations that go together. And so that'll give me, for loop 1, I'll have R2 equals R4 plus R1, and that'll be R2 e to the I theta 2 equals R4 e to the I theta 4 plus R1 e to the I theta 1, and both of the length and angle change for R4, only angle changes for length 2. So I'm going to have a type 2 vector, a type 4 vector, and a type 1 vector in that loop, which will give me an equation that looks like R2 omega 2 I e to the I theta 2 equals R4 dot e to the I theta 4 plus R4 omega 4 I e to the I theta 4, and then this type 1 goes away. So that's going to be my velocity equation for type 4. Okay. For loop 2, I'm going to have R3 plus R5 equals R6 plus R7, and that'll give me R3 e to the I theta 3 plus R5 e to the I theta 5 equals R6 e to the I theta 6 plus R7 e to the I theta 7. R6 changes, theta 5 changes, theta 3 changes. Some point, I also should note that theta 3 equals theta 4, so omega 3 will be equal to omega 4. And so I've got a type 2 vector, and a type 3 vector. So this one's going to be R3 omega 3 I e to the I theta 3 plus R5 omega 5 I e to the I theta 5 equals R6 dot e to the I theta 6. That should be a 6 right there. And so that's my other velocity equation. Now, we want to think, since this is a mechanical advantage, not just strictly a velocity problem. We want to look, we've got our input here at D, and we've also got, sorry, that's our output. Have the arrow going the other way for an output. And we've got our input here at G. Okay, and that's on link 2. And so the velocity of G is just going to be a vector. It's going to be the vector of G with respect to O2. And so that's on link 2. And then this one's velocity of D. That's just a point on link 6. And so hopefully you can see that the velocity of G with O2 is just going to be RG O2 times omega 2. And then the velocity of point D is just going to be R dot 6. Okay. Now omega 2 over R dot 6, that's something I can get out of my two velocity equations. So I'll do whatever algebra I need, but I only need to do the part that gets me this relationship, because once I know R6 dot in terms of omega 2, then I know all I need to solve the problem. Okay, and so what that tells me is I just need to find omega 4 in terms of omega 2, and then since omega 3 equals omega 4, I just need to find R6 dot in terms of omega 3. Okay, so I don't need to do a full velocity analysis. I just need to find a few of the relationships so I can find the mechanical advantage.